Imagine falling, not through air, not through water, but through reality itself. A place where space bends, time slows, and the laws of physics begin to break down.
Today, we're going to answer one of the most terrifying and fascinating questions in all of science. What would happen if you entered a black hole? And before we begin, if you want more deep, mind-expanding journeys through space and the universe,
make sure you subscribe to Give Me Space, because this is just the beginning. Let's begin. A black hole is not a hole. It's not a tunnel. And it's not empty.
A black hole is an object with gravity so strong that nothing, not even light, can escape it. Most black holes form when massive stars die. When a star at least 20 times the mass of our sun runs out of fuel,
It collapses under its own gravity in a supernova explosion. What's left behind is a core so dense that all its mass is crushed into a single point. This point is called a singularity. Around it lies a boundary known as the event horizon.
This is the point of no return. Once you cross it, escape is impossible, not even at the speed of light. Now imagine you're in a spaceship, slowly approaching one. At first, it might not look like much.
black holes don't glow. They don't shine. But what you would see is something far stranger. The stars behind it begin to bend, twist, and stretch into arcs. This is gravitational lensing. The black hole's immense gravity bends light around it, like a cosmic magnifying glass. You might even see a glowing ring surrounding it. This is the accretion disk, a swirling mass of gas and dust spiraling inward. It shines with incredible energy. Temperatures can reach millions of degrees.
get too close, and you'd be vaporized instantly. So for now, you stay clear of it. You aim directly toward the darkness. As you get closer, something strange begins to happen. Time itself starts to behave differently.
Not for you, but for anyone watching from far away. To them, your clock slows down. Your movements become sluggish, then slower, then almost frozen. This is gravitational time dilation. The stronger the gravity, the slower time moves relative to others.
to an outside observer, you would never quite cross the event horizon. You would appear to linger, fade, and eventually disappear. But from your perspective, everything feels normal. Your heartbeat is steady. Your thoughts are clear. You continue forward.
Unaware that to the rest of the universe, you are almost frozen in time. And then you reach it, the event horizon. There's no line, no warning, no sudden jolt. You simply pass it. And in that moment, everything changes.
You are now inside the black hole. From here, there is no turning back. Not because you lack the strength to escape, but because escape is no longer part of your future.
The very structure of space and time has shifted. Moving forward in time means moving closer to the singularity. And now, the real effects begin. As you fall deeper, gravity becomes stronger and stronger, but not evenly. Your feet, being closer to the center, feel a stronger pull than your head. This difference is called tidal force.
At first, it's subtle, but it grows rapidly. Your body begins to stretch, slowly at first, then more and more. Your spine elongates, your arms extend, your entire body is pulled into a thin line. At the same time, sideways forces compress you inward. You are being stretched and squeezed simultaneously. This is spaghettification, an extreme effect caused by intense gravity gradients. Your body cannot resist it. Cells are torn apart. Molecules break down. Eventually, even atoms are ripped from one another. You are transformed into a stream of particles, falling endlessly inward. If the black hole is small, this happens quickly, violently.
But if it is supermassive, millions or billions of times more massive than the Sun, the process is slower. You might pass the event horizon without feeling anything at all. But eventually, no matter what, the stretching becomes unavoidable. And still, you fall. Deeper, closer, towards something we cannot fully understand. Because beyond this point, our physics begins to fail. According to our best theories, at the center lies the singularity, a point of infinite density, infinite gravity, zero size. But infinity is a warning sign in physics. It tells us that our equations are incomplete, that something is missing. Some scientists believe that space and time themselves break apart here. Others suggest that inside a black hole, the rules of reality are entirely different.
There are theories that black holes could connect to other regions of space, or even other universes. Wormholes, quantum tunnels, bridges through space-time. But we have no proof, no way to observe, because nothing that enters can ever come back to tell the story. And yet, if you could still see, your view would be unlike anything imaginable. The universe outside would appear warped. Light bends in extreme ways.
Above you, the outside universe compresses into a shrinking circle, a bright, distorted window to everything that was. As you fall deeper, that circle shrinks. Time outside begins to speed up, faster and faster. You might witness the distant future of the universe unfold in moments. Stars being born, galaxies colliding, cosmic structures evolving over billions of years, all in seconds, until eventually even that light fades and darkness takes over.
There is one final mystery, one that challenges everything we think we know. What happens to the information that falls into a black hole? In physics, information cannot be destroyed. It can change form, but it must always exist. And yet, black holes seem to erase it completely. This is known as the information paradox, a contradiction between quantum mechanics and general relativity. Some theories suggest that information is stored on the surface of the black hole, encoded like a hologram.
Others propose that it slowly escapes through something called Hawking radiation, a faint energy emitted over unimaginable timescales. This question remains unanswered, one of the greatest mysteries in modern science. So, what would happen if you entered a black hole? You would fall. Time would warp around you. Your body would stretch beyond recognition, and you would ultimately be destroyed at the most extreme point in the universe. But in doing so, you would encounter physics at its absolute limits.
A place where space bends infinitely, where time loses meaning, where reality itself begins to unravel, and perhaps, just perhaps, something even stranger lies beyond. If you enjoyed this journey into the unknown, make sure to follow, like, and comment what you want to explore next, because in the next video, we might answer an even bigger question. What actually lies beyond the observable universe? See you in space.